So here are some specific methods to graph equations. We've learned 2 out of 3. So far we've learned how to use an XY table, which works with any kind of graph. And now we're learning how to graph with X and Y intercepts, in which case we put our equation in standard form. And then later we'll learn another technique. And using X and Y intercepts works for a lot of graphs, but not all, because they have to have one distinct X intercept and one distinct Y intercept to work. And we have equations that either will not have both or will have an infinite number of each. But for most linear equations, it will work. X and Y table works for everything, which is why we learned that technique. So let's look at some examples. So here's a basic example of finding the X and Y intercept. So use the process that you learned in the first video to find the X and Y intercept for this particular equation. Let's go ahead and try that and then check before graphing. So did you get 4, 0 for your X intercept and 0, 2 for your Y intercept? If you did, then you did a great job. If not, that's okay. Let's look at it. Either way, I want to show you a shortcut that I use, and I've kind of demonstrated it with my math, but a lot of times I do this in my head. So when I'm solving for my X-intercept, I imagine that my term with the Y in it's not even there, and a lot of times if the math is pretty easy, like with this one, I can imagine dividing both sides by 2 to get X by itself, so I know that X is 4. So I can figure that out pretty easily. And then when I go to solve for my Y-intercept, I imagine removing the X term, the term with the X in it, and I can imagine dividing both sides of that equation by 4 to get Y equals 2. So a lot of times I can do these without showing math. Now when the equations get more difficult or have fractions, sometimes I have to show the work. So go ahead and graph these and check back. So let's check a couple of things. First of all, make sure your graph is correct. Second of all, let's make sure that you have arrows on both ends of your line. That's extremely important in your notation. And then of course that you have labeled the line with its name or equation in standard form. Now let's move on to the next example. So try this one and see if you can imagine what your X-intercept and Y-intercepts will be. See if you can do it without showing all your work, and then check back. Did you get 1, 0 as your X-intercept and 0, 4 as your Y-intercept? If you did, then you have the right answer, so great job. And notice I'm showing you steps here that I can actually do in my head. Again, I can imagine when Y is 0, just removing that term, and I see 8x equals 8, so I know x has to be 1. And then when I'm trying to find my Y-intercept, I can imagine removing that term, 2y equals 8, so y has to be 4. And make sure that you put your 0 in the right place when you're setting up your ordered pairs. Go ahead and graph these and check back. So how did you do? Did you graph it correctly? Also make sure that you have arrows on both ends of your line and label the line. Okay, great. Let's move on. For this equation, notice it is not in standard form, and we want to have our equations in standard form. So go ahead and put this equation in standard form. So if you end up with negative x plus y equals 4, then you have the right equation in standard form. So now go ahead and find the x and y intercept and check back. So did you get negative 4, 0 for your x-intercept? And did you get 0, 4 for your y-intercept? Usually if students miss this one, it has to do with the negative on our 4 over here. Make sure when you let y equal 0, so right here, this is going to disappear. You end up with negative x equaling 4. So keep in mind that you have to multiply those sides by negative 1 to make that x positive, which is going to make your 4 negative. Go ahead and graph those and check back. So how does it look? Are you ready for the next problem? Let's go ahead and move on. So for our next equation, we have y equals 4. Now this is a little bit of a stumper, right? These are a little bit not typical problems. So you're going to approach equations that are y equals some constant c or x equals some constant c the same way. You're going to use an XY table regardless of whatever technique you're working with. So we're going to start by putting it in standard form. So we put it in, and this doesn't matter if you're using XY tables or intercepts like we're using now. You want to go ahead and put it in standard form to help you understand how this works. So we end up with 0x plus y equals 4. We know that if a term is missing, that there's a 0 for the constant, right? So if our term with x is not there, it doesn't mean we don't have x's. It means that the coefficient of x is 0. It just means the coefficient of x is 0. So there have to be x's, right, in order for us to have ordered pairs, because ordered pairs have both x's and y's in them. So we just know that there's an understood 0 in front of our x. So from here, let's think. Let's draw a really basic XY table. I'm going to make it look like this. So basically, having the 0 in front of the x means that anything we put in the place of x is going to be multiplied by 0. So what happens whenever you multiply anything by 0? You get 0, right? So I can put anything in the place of x, and it's going to go away. So it'll still be our x value, but when it comes to solving the problem, when we substitute it, it's going to disappear. So for example, if I use -1, 0, and -1, if I put -1, well actually let's change that to -1, 0, and +1. If I put -1 in the place of x, I'm going to get 0 times -1 plus y equals 4. And when I do that, I end up with 0 plus y equals 4, so y equals 4. Now let's try putting 0 in the place of x. So if I do that, I get 0 times 0 plus y equals 4. 0 plus y equals 4, so y equals 4. So in both of those cases, y was 4. Now let's put 1 in the place of x. Are you starting to see a pattern? So there we'd get 0 times 1 plus y equals 4. So 0 plus y equals 4, so y equals 4. So no matter what I put in the place of x, what will your y value always be? 4, right? It's because of the fact our coefficient of x is 0 that our y value will always be 4 regardless of what value we have for our x's. And so what my graph is going to look like here is that y will always be 4. So if x is 0, y is 4. 1, 2, 3, 4. So that's actually our y-intercept. And then if x is 1, y is 4. If x is 2, y is 4. If x is -2, y is 4. If x is -1, y is 4. So y equaling 4 is a horizontal line that intersects our y-axis at the y-intercept. And that's what it looks like. So we're just going to label this y equals 4. But you can use the standard form of the equation and a quick little table to help you think through, should that be a horizontal or a vertical line. So let's move on to the next example. Here we have x equals -2. So for x equals -2, let's write that in standard form. So we would have x plus 0y equals -2. Again, when a term is missing, that means there's a 0 for our constant. In this case, the term with y is missing, so our coefficient of y is 0. That's why we don't see it. But our y value still exists. You have to have x and y values in order to work in the coordinate plane, right? Okay, so let's make a quick little table here. XY table. You can't really find an x and y intercept because there is not both an x and y intercept. We saw that back up here. There's only a y intercept for this line. So what intercept do you think we'll have here? If you think it's x, you're right. But let's prove it. So in this case, I'm going to pick anything I want for my y instead of my x. Usually we pick for x's, but here we'll pick for y's. So let's do 2, 0, and -1. I always like to pick a 0 just to see what happens around 0. So when we substitute these in, we're going to get x plus 0 times 2 equals -2. So x plus 0 equals -2, so x equals -2. So when y is 2, x is negative 2. Now let's substitute 0 in the place of y. X plus 0 times 0 equals negative 2. So x plus 0 equals negative 2. So what's x? It's negative 2, right? And now let's put negative 1 in the place of y. X plus 0 times negative 1 equals negative 2. Obviously, we're going to end up with x plus 0 equaling negative 2. So again, x is negative 2. So do you see that regardless of what we put in the place of y, x will always be negative 2? And that's what this equation means, x equals negative 2. And it's because the fact the coefficient of y is 0. So let's go ahead and graph this. So the first ordered pair I have is negative 2, 2. So we're going to go over sideways to negative 2 and up 2, 1, 2. Then we have negative 2, 0, which look, what is that? The x-intercept, right? And then we have negative 2, negative 1, negative 2, negative 1. And basically what we've seen here is no matter what our y value is, our x value will always be negative 2. So x equaling negative 2 is actually a vertical line that has an x-intercept of negative 2. This vertical line intercepts the x-axis at negative 2. So this is the equation, x equals negative 2. Let's go to the next equation. All right, go ahead and find the x and y intercept for this and then check back with me. You should see that something kind of interesting happens. So did you figure out that the x and y intercepts are both 0, 0, the ordered pair for the origin? Well, that's really only one ordered pair because they're the same ordered pair. So we've only found one point. And if you don't quite understand how I got 0, 0, just take a minute and look at the math and pause the video. All right, so I'm going to go ahead and graph the 0, 0. So this means that my line is going to come through like this. We're not exactly sure how, but it's going to intersect at the origin and not actually hit the x or y axis anywhere else. So since we only have one ordered pair, we have no idea what the line looks like. We need another ordered pair. So what we're going to do is solve for y in terms of x and then choose an x value to find the corresponding y, just like we did when we were solving for y in terms of x and working with functions. So anytime a technique you're learning doesn't work to give you enough ordered pairs to graph, you go back to solving for y in terms of x and then choose an x and find the corresponding y. So go ahead and solve for y in terms of x and then set up an xy table. And why don't we let x equal 1 just to keep it simple. So let's check and make sure you have the correct equation. Y equals 3/2 x plus 0. So maybe 1 isn't the best x value to put in. If you've already done that, that's fine. Maybe 2 would be better so that we can cross cancel with the denominator, not have to deal with fractions. So I'll try both. I'll put 1 in the place of x and 2 and see what we get. So you try that as well. So here are the two ordered pairs I ended up with. 1 and 1.5 and 2 and 3. For 1.5, you just have to estimate when you're doing that graphing. So let's go ahead and graph all three ordered pairs, the 0, 0, and then these two, and then draw a line through it and check back. How'd you do? Great. Okay, let's go on and try the next problem. So now we're going to be working a little bit with fractions. Sometimes when you get your x or y intercept, they could be fractions, and that's okay. So go ahead and find the x and y intercept for this. So you should have 1.5, 0 for your x-intercept and 0, 6 for your y-intercept. So let's go down to graph 1.5, 0. You're just going to go over 1.5, and then you know how to graph 6. Let's move on and try the next equation. Put this in standard form and find the x and y-intercepts. All right, let's see how you did. The x-intercept was 6, 0. The y-intercept was 0, 2. And there's the graph. I'm also going to scroll back up in a second and show you the graph for the previous one so you can see it, and then we'll be done. Great job! I hope you enjoyed this video and learned a lot. Have a wonderful day.